Now, my two panelists here are I would say, application people. You're interested in applying things, whereas I'm a pure scientist, I think. So that's why I feel like an odd person out.
Hey, would you hold your microphone up?
I'm sorry.
Closer? There
Yes,
we go.
sure.
Thanks.
All right. So I am interested in perception. I teach perception. I'm interested primarily in visual perception. So I'll tell you a tiny bit about my own perception, my own research. I don't want to put you to sleep, and then I'll maybe move over to some other story that you might think is interesting. I did a little bit of, let me take a step back and say, I'm not sure if you realize this, but you and I have a big wrinkly cortex underneath our skulls, and different parts of the cortex respond to different kinds of input. Back here is visual input, this is auditory cortex, this is body cortex. So we have several different senses, and obviously we're talking about pain, so we're talking about touch. Okay. So I did a study in which I asked people to hold things which were moving, and what I expected is that body cortex would be active, not surprisingly, right? And I put their brain into a magnet. They were lying there with their brain inside a big magnet, an MRI machine, where I could tell which part of the brain was active. They're holding on to something which is moving, and not surprisingly, body cortex is active, and this was shocking to me. I'm not sure if you'll be shocked as I was, but the visual cortex was also active. So I don't know if you remember back when you were in elementary school, back when you wanted to go to kids that had matchboxes and Hot Wheels, like I did when I was a little kid, and they had a little Hot Wheel, and I said, "Oh, let me see it." And you know what they'd say? "You look with your eyes, not with your hands." Actually, no, you don't. You look with your hands because you hold things and you see as a result. Your visual cortex gets active. That's kind of freaky. All right. So as I said, I'll just tell a little bit about my own research and then move it over to another story, which I think might be interesting, let's say. Talk about some people have lost a limb, let's say. A person who might have lost a limb, let's say an arm, they've lost it they still have their upper arm, don't have the lower arm, don't have their hand. And you might have heard about this. It's called a phantom limb. They still feel it, actually, and they might, in fact, feel pain in it. They might say things like this. They'll complain. "Doc, I feel as if I'm digging my fingernails into my fist." So they're digging trenches. And you say, you mean that hand that you don't have? And they say, "Yeah, that hand right there, right?" Well, what are you going to do? For me, if I am digging my fingernails into my fist, I go like that, and I feel better. Or if I have my hand twisted around my back, and I want to relieve some of the pain, I go like that, and it feels fine. But if I don't have an arm, what am I supposed to do? I can't do it. Well, remember what I said, that when you touch something, it'll activate visual cortex. This is kind of the opposite side of the coin. So there was this guy in California, you might have heard of him, named V.S. Ramachandran. He's a well-known guy. He's written several books, and he's interested in phantom pain. He's interested in some other things. What he did is he asked people that have phantoms, let's suppose I have a phantom right arm, and I feel, as I said, my fingernails digging into my hand, but I can't relieve it because I have no hand. Well, how about this? How about if I take, now Ramachandran is a vision scientist as well as a physician. How about if you take a mirror and put it between your legs, and I look at it, and the funny thing about mirrors is that we don't realize that what we look in the mirror is actually not there. It makes the room look bigger, right? And I look in the mirror, and there's my left hand, and there's my right hand in the mirror, except I don't have a right hand. So, and the funny thing about phantoms is they feel like they're actually in space somewhere. I feel like it's right here. Well, how about if you take your actual left hand and place it in the mirror image so that it's at the same location as the phantom? Okay. Now, squeeze your hand so that it looks like it feels like your right hand feels. And put it in the same location. Now, release your hand, and you know what happens. That's right. Feels like you're releasing it. Is that a beautiful story or what? That is beautiful, I think. And that is the kind of thing that wasn't discovered until 1990s, which for me feels like yesterday. I know for young people in my classes that I teach, it's like a long time ago, but 1990s is not very long ago for medical science. So what people used to do, think about it. If you have a phantom because of an amputated limb, physicians said, well, it must be because of ragged nerve endings sending signals of pain up to the brain. So how about if we cut it off so that it's a little bit cleaner this time? Let's cut it off, amputate it a little bit higher, do it cleanly, and the patient says, "Hey, that feels great, doc," for a day. 100% of the people who had more amputations had the phantom pain return. 100%. So it doesn't work. It isn't about ragged nerve endings. It's about idle cortex. If you have cortex, it's like real estate in Manhattan. It's going to get used. So if you have this cortex, it used to be connected to the arm, and it isn't connected to the arm because there's no arm anymore, right? So it gets invaded by the other parts of the brain that are next door. The other parts of the brain that are next door, if I lost my lower arm, the upper arm in my cortex is connected right next to it. And so if I go like this, oh yeah, I feel like touching my fingers. How about if I take a drop of water and put it on your arm so that it dribbles down your arm? I feel you dribbling, a drop of water down my fingers when you do that. And how about this? How about if I stroke your cheek? Yeah, I feel that in my cheek, and I feel it like you're touching my index finger, middle finger, ring finger. Because the way that the body is laid out on the body cortex, upper arm is next to the lower arm, and the face is next to the lower arm. So it gets invaded by the face, it gets invaded by the upper arm. I think that's all I have to say. I'll turn it over.